Okay, so let's talk about some major network standards architecture. The very first one is called OSI 7 layers. So Open Systems Interconnect. So OSI stands for Open Systems Interconnect. And unlike the architecture we've looked at so far, this one has 7 layers. Okay, so the network architecture model we looked at before this one, it had at the very bottom called physical layer. Above the physical layer it had data link. Yeah, I guess I won't use that layer word here. Above data link we had network layer, network or internet, and we did have after that transport layer, and then at the very top we had the application layer. So all these layers we learned about, they are already built into this open systems interconnect or interconnection architecture, OSI 7-layer architecture. But in the OSI architecture there are 2 additional layers that aren't really used today. So those are something called session layer, okay, and then above the session layer they have something called presentation layer. Okay, so presentation and the session layer, these 2 are what is actually new. Okay, so let me just use a different color here. So the question is, what are these layers doing? And in terms of the presentation layer, the main role is to take care of things like encryption. Encryption is one thing. Another thing is something like encoding. So remember we talked about ASCII encoding. So when the 2 hosts, they use different types of encoding schemes, somehow they have to reconcile the differences, and in the OSI architecture the reconciliation was done in the presentation layer. Another possibility is doing compression. So when the data is sent over a network, it's the best to compress data as much as possible just to reduce the amount of traffic. So that's something originally proposed by the OSI architecture, but in reality all these things are actually done at the application layer today, and they don't really use this presentation layer. The same thing applies to the session layer, because what this session layer was supposed to do was, in the case when you were interacting with another host, and if something goes wrong and then the connection gets disconnected, you don't want to restart from scratch in terms of your interactions. So in this case, the nice thing could be your ability to roll back and then start where you stopped. So one very nice example of this is when you're trying to download a file and somehow something goes wrong, you have to close your web browser or something, and it would be nice for you to be able to continue from where you stopped. So the session layer was supposed to take care of those types of things. However, again, they realized that all these things can be really done in the application layer. So that is why the session layer is also not used very widely today either. So provides the ability to roll back and resume. Okay, so that's the open systems interconnection architecture. And as you can see, all the major things we talked about in that standards architecture we talked about before this, the layers are really built into this. And another competing standards architecture out there, I mean not competing anymore, but they used to compete with each other, was something called TCP/IP. Okay, so TCP/IP, and TCP/IP stands for, I would say, transmission control protocol and internet protocol, and in short, TCP/IP. And as you can see here, TCP/IP only had 3 layers. So it had the application layer, it had TCP, right? Not TCP, but the transport layer. And then under the transport layer, they had internet layer. And let me make a correction here. So in the original OSI architecture, they don't have something called internet there. They only have network layer. Okay, so network is the actual layer in the OSI architecture. Internet is the layer that is really in the TCP/IP architecture. And what's interesting about this one is these 2 lower layers, namely the physical layer and the data link layer, they didn't really have their own layers at all. So what they had to do was they had to actually borrow from the OSI. So what ended up happening was they simply used what was available in the OSI architecture. So used the data link layer from OSI here, and used the physical layer from OSI. So what ended up happening here is some sort of a hybrid. The first 2 layers borrowed from the OSI architecture, and then the upper 3 layers, internet, transport, and application layer, these are something proposed by TCP/IP architecture. Okay, so that's why what we're using today is called hybrid OSI TCP/IP architecture, because it's the combination of the OSI layers and then the TCP/IP architecture.